we are into the classification of robots. Basically, 4 different configurations are there, and you take any industrial robot which is engaged in painting or drilling or pick and place, assembly and welding, whatever the operation, all those robots will be falling under these 4 important groups. And these groups are made based on their physical configuration. The physical configuration or work volume of the robot already we have explained. It is an imaginary envelope generated around the robot when the end effector is extended around its manipulator. So the arm is extended around its manipulator. The possible ways by which it can reach an imaginary cover, the cover which is developed will be work envelope or work volume of the robot. And under this, we have 4 important categories or classifications based on the physical configuration. In this similar way, we have to say the Cartesian coordinate robot, cylindrical coordinate robot, polar or spherical coordinate robot, and the articulated robot. Articulated robot is also called giant arm configuration or SCARA, selective compliance assembly robotic arm. Since it resembles to the human arm, okay, the SCARA or articulated robot, it is just like an articulated hand of a human being, so that it is called as articulated robot arm. And the Cartesian coordinate robot, the Cartesian coordinate robot will be developing a work volume in this rectangular form, so that it is also called a rectangular coordinate system. So all these x, y and z movements will be linear, so that the coordinates of this robot will be represented by x, y, z, that is x, y, z only. The x, y, z coordinates, it will be x, y, z only. Okay, and it is also called LLL robot, or simply you can say it is 3L robot, because along the x, along the y, along the z, linear movements will be there. Since I told you already, the spatial resolution and the accuracy and repeatability are important things, and another one, a control is also important thing. These we have to discuss. Okay, let me discuss the spatial resolution. Imagine that you have been given this cubical or rectangular one small cake you have been given, and your 10 friends are there. 10 friends can equally divide it and eat. That means the work volume generated by these robots are in a rectangular cubical arm, and the spatial resolution of these robots will be equally or uniformly distributed entire work volume of the robot. Entire work volume of the robot will be having a similar size and similar kind of spatially resoluted subsets of work volume, so that we can say the repeatability and accuracy of the robot will be uniformly distributed throughout our entire work volume. Okay, and since this is a linear type, what happens is only the initial and final points are important. In between, how the robot is forming its path is not important. Okay, just at a particular point pick, and at a particular point it has to drop. And what is the acceleration, velocity and displacement the arm or end effector has to generate, it is not important. Only the initial conditions are, final conditions are important. Just like you say x1, y, x0, y0, z0 is the initial position of the part, and it has to move to xn, yn, zn. Okay, these are the 2 important points the controller has to remember, so that the controller required for these robots will be very, very simple one. Very, very simple one. And since the movements are just like a frame structure, mechanically these Cartesian coordinates are very, very rigid enough, mechanically stable enough, so that they can be used for heavy part lifting. We can move the parts from one point to the other location, to the one location to other location in the industry. So it is also called as giant robot. Giant robot in the sense it is not giant. It can able to perform heavy work, and most probably in application point of view, it will be used for pick and place, machine loading and unloading, and a simple pick and place operations you can do. Okay, simple pick and place, machine loading and unloading, and helping on the conveyor it will be used, where else very straight motions are required. In between path is not important. Okay, these are the applications of the robot. Okay, and what are the disadvantage? If you want to say the disadvantage, since all are linear, the flexibility of the end effectors is not good enough, so that they cannot be used for other applications like assembly, machine vision applications, testing, and all these they cannot be used. Okay, this is about the Cartesian coordinate robot. I hope you understood this. Next, let me go to, this is what I have written here, and you can go through it, and some of the additional things also I told that you have to remember, or just I'll write it at the end of this session. And let me come to the cylindrical coordinate system. So during the previous class I had written cylindrical coordinate system. The cylindrical coordinate robots are also called as 1R and 2L robot, RLL. One is rotational and the other two are linear. Okay, one is rotational and other two are linear. The work volume generated by these cylindrical robots are in the form of two concentric cylinders, or simply you can say a segment of a cylinder. Segment of a cylinder, or simply you can say cylinder. Hence, the work envelope, the sweeping of this end effector forms the cylindrical shape, so that the work volume of these robots will be in the cylindrical form, and since these robots are also called as cylindrical coordinate robot. Okay, first one, the work volume generated by these robots will be in the form of cylinder, so that these are called cylindrical coordinate robots. And coordinates are r, theta, z. R is a retracting of the end effector, moving front and back. It is R is retracting. Okay, r, theta, it is along this vertical limb rotation, and z is the up and down movement, so that you can say here one linear and two rotational involved. Okay, next point, what about the mechanical stability? The mechanical stability of these robots will be good enough when arm is not extended much. Okay, just example, you can say how much Varun or anyone, how much load you can carry? Any one of you? Any one of you, how much load you can carry? Are you there in the class, Gagan? Gagan, Varun, Shivaprasad, Sumit Kumar Mandal.
Yes, sir.
Yes, sir.
Yeah, you see, your response is very, very important. If you keep quiet, it is forcible. And how much load you can carry? Just I am asking you, anyone. I am not asking sensitively. How much load you can carry approximately?
Approximately on 70 to 80 kg, sir. 50-60 kg, sir.
Okay, 60 kg. Okay. Or you say you can carry flexibly without having much more fatigue. You can carry 30 kgs, for example. And is it possible that you can carry this 30 kgs just by extending your arm? Is it possible? Just I will be giving the example again. This is very, very important. See, during the previous class we did this. See, I'm taking a person, I'm taking a man. Look here, when the arm is extended, So this is when arm is extended. This is a person. This is a person, you say. And you can able to carry the load. You can able to carry the weight like this, whatever it is, 60 kg or 70 kg. Is it possible to carry the load 60 kg here by extending your arm horizontally?
No, sir.
Yeah. And see, in the robotic, it will consider, you can see that when you lift the load like this by extending the arm like this, what happens? The mechanical stability will not be there. The mechanical stability will not be there. The results will be erroneous. The repeatability and accuracy will not be good. See, if I told you to write A here, if I wanted you to write here A, you can write A here. And at the same time, what I'm doing is I'm going to give you one stick in your hand. I'm going to give you a stick in your hand. Okay, it is a stick, you say. This is a stick I have been given you. And I'm going to attach a pencil at the end of this. Okay, I wanted you to write on the board. Is it possible to you can write accurately? No, it is not possible. The accuracy and repeatability will not be good once the arm is extended more. You understood my point? You understood? So here also, here,
Yes, sir.
mechanical stability of these robots are not good enough as compared to the Cartesian coordinate robot. And you know that the spatial resolution of these work volume of the spatial resolution of the work volume will not be having for the same segment, it will not be having the similar shapes, so that the repeatability and accuracy will not be good throughout the work volume of the robot. You can see here, you can see during the previous class I have shown, see, for the same number of divisions, for 1, 2, 3, 4, 5, 6, for 12 divisions I have done, for the same 12 divisions, the shape of this segmented work volume will be different at the different location. That means to say the accuracy will be very good at the inner portion of the worker lobe. Once the arm is extended outside, the accuracy and repeatability will not be good enough because of the mechanical stability of the robot end effector is not good. Correct, no? So that what we do is, that means to say, it is not the sensitive, I cannot say. For this, to avoid these mechanical instability and errors involved in this, high level microcontroller will be required. The controller required will be of sophisticated one as compared to the Cartesian coordinate system. Okay, as compared to the Cartesian coordinate system, the controller required will be better than one. And another, since the rotational also included in this, since the rotational joints are there, the independent rotations and flexibility will be more as compared to the Cartesian coordinate systems, so that it can able to remember more points. So it can able to generate a required definite path. Correct, no? So that the controller should have very good one as compared to the Cartesian coordinate robot. And what about the application? The application wise, you see that once we go on add up the rotational joints, the flexibility will be increased and it can able to perform very complicated and complex tasks it can able to do. So application. So I told you whatever the previous robot can able to do, this robot also can able to do. So this also can be used for a pick and place, a small part or components machine loading and unloading. We can use it. And apart from this, we can use for a simple paint spray and the welding operation. Simple welding and simple paint spray operations, we can use them because one rotational joint is there. Okay, one rotational joint is there. And the accuracy and repeatability will be good along the vertical direction, one below the other. You have seen that. Just like I have arranged the bricks, the work volume have been segmented. The shape of the work volume will be same one below the other. You have seen that during the previous class. Correct, no? And next, anything you want to ask me in this, please tell me. And try to prepare here only. Don't keep any time, pending time for the preparation. We'll be having very good interactive time. You can prepare here only. The next one, the same thing I have written here. And let me come to the spherical or polar coordinate system. The spherical or polar coordinate system, the coordinates are r theta phi. First one was x, y, z. The second one was r theta z. And here it is r theta phi. R theta phi is the coordinate of the robot. You can see that r is the retraction of okay, it's not working. You can see that this is this one. It is the arm, it can be extended front and back. It is a retraction r, and this is theta, and this will be z. R theta z, or you can say this as the theta, this as z. It doesn't make a difference. Okay, since the work volume generated by these robots will be a segment of a sphere, appears to be a segment of a sphere, so that these robots are called spherical or polar coordinates robots. And let me look into the mechanical stability. The mechanical stability of these robots will be lesser than the mechanical stability of cylindrical and Cartesian coordinate robots. Because under an additional rotational joint is involved in this. Since the rotational joint is involved, just now I told you, I have shown you the stability, mechanical stability, repeatability and accuracy will not be good once the arm is extended more. So that here the controller required will be better than the or sophisticated than the cylindrical and the Cartesian coordinate robot. And where all we can use them, the application wise, if we say, since the two joints are rotational, we can use them for flexibility and able to use for the assembly operation and very good the welding operations, along with the previous robots what it was able to do. At critical place it was doing, and it was doing simple welding operations, simple the paint spray operations, and it was doing machine loading and unloading. Along with that, what it can able to do is it can be used for a complicated and very complicated painting and the welding operations. These robots can be used because of only the point is that the two rotational joints are there. Okay, and the mechanical stability of these robots will be lesser than the cylindrical and the Cartesian coordinates robots. So once the mechanical stability is not good enough, then the accuracy and repeatability will not be good enough as compared to cylindrical and the Cartesian coordinate robot. Any points are there to discuss in this? So maximum if you go to any industries, any industry they are engaged in the manufacturing, they will be having specifically the spherical and the SCARA robot. Spherical and the SCARA robot you can find. And another one you have seen the overhead conveyors. The overhead, this one will be there. It can the trolley will be there, and by teach pendant they will be guiding, and the whole entire the factory it will be having the railing on the top. That will be just like a Cartesian coordinate robot. Okay, I hope any no discussions are in this. Then let me go to the next one. The giant arm robot. Giant arm robot. And to write this, if you feel difficult, even you can use the, you can write like this also, no problem. I'll be showing you. If you feel difficult to write, you can simply write like this. Say the different robot the configurations I'll be showing you. And if you feel difficult to write, see our point is not to write a decorative figure. It is not required. Okay, you have to show specifically what I required. You have to show that. See, look here. The first one, the Cartesian coordinate robot, how it can be shown. I'll show. Very simple mechanism. Link. One link. Cartesian coordinate robot. Very simple figure. Is it not possible to show? And you can show the R mark here. This moment is okay. This moment is X direction. And this direction and this direction. Okay, arrow marks X, Y, Z. You can write. Is it possible to write? You can write R X, that is X, Y, Z. Or is simply you can write X, Y, Z itself. X, Y, Z. This is the Cartesian coordinate robot. Okay, and how we can write the cylindrical coordinate robot? The cylindrical coordinate robot can be written like this. See, you can write like this: cylindrical coordinate robot with the rotation at this end. It can rotate here. You understood my point?
Yes, sir.
Yeah, and rotation here. And another one, this is Cartesian, this is cylindrical, and another one the spherical. How you can write the spherical or polar coordinate system? You can write like this. Look here. Okay, and it can rotate here, and it can rotate here, and it will be having the end effector at the end. End effector at the end. This much is enough. Okay, this much if you write, it will be more than enough.
Okay, sir.
This is called as end effector of the robot. Okay, this is called end effector of the robot, and this I'll write for all these things. That's all. End effector of the robot, and it will be having rotating joint here, and it will be having rotation here also, and the arm can be moved front and back. Just you can see here, the arm can be moved front and back. No, it will be linear and it will be rotational, and this will be rotational. Okay, this is called a spherical coordinate system. And another one, if you talk about the other one, what is that? The articulated robot. If you want to talk about the articulated robot, it will be like this. You need not to write a very complicated figure and show that you can able to do it. It is not required. See here. That's all.
Yes, sir.
Okay, now. Very simple. Try to reduce the figure. Try to reduce the figure and write it. See, this is the rotation here, and rotation here. Okay, rotation here also. You understand my point? Okay. Okay, here also it is having rotation, and here also I'll show here the rotation how it will be. That's all. You need not to waste too much of time to write it. So if you happen to get this for the test also, please write this one only. You can see that you can find theta 1, theta 2, theta 3 here. Correct? No? This is the Cartesian coordinate, robot, linear, linear, linear. So this will be 3L, 3L, and it will be linear. You are understanding me? And it will be linear movements.
Yes, sir.
Yeah, it will be linear movement, and this will be rotation here. This arm can be rotated like this. This arm is there, no? For example, this arm can be rotated like this. About this point, it can be rotated like this. You understood my point? It can be rotated. You understood? So this arm can be rotated. This arm can be rotated like this, so that it is a rotation along this axis, and this is the retraction, and this is moving up and down, so that this is called 1L and 2R robot. Correct? Okay.
Yes,
And
sir.
the next one, and here it can able to rotate here. Okay, it can able to rotate here, and it can able to rotate here. It can able to move like this, so that it will be having 1L and 2R. And the last one, it is giant arm articulated robot, or simply a SCARA robot. You can say this is having rotation here, and rotation here, so that this is called 0L and 3R robot. And you can see that once the rotations are increasing, the mechanical stability goes on decreases, and it will be very worster in this case. Mechanical stability, repeatability, and accuracy will be very, very less once, because of the rotation joints are there. As compared to this, this will be having little more better. As compared to this will be having little more better. And this is, you can see that your house will be constructed the circular or spherical or rectangular.
A rectangle, sir.
Yeah, because the rectangular is having very good stability, mechanical stability. So that, correct, no? Since
Yes,
the
sir.
rotation once goes on, increases the rotations, rotating joints, what happens? The mechanical stability will be decreased, and the repeatability and accuracy will be decreased. So that we should have to have the better controllers we required. Okay, and these robots, okay, and okay, let us discuss these differences between them. Okay, so the coordinates are Cartesian. This is a Cartesian coordinate robot. The work volume generated will be Cartesian. The work volume generated will be cylindrical. The work volume generated will be spherical. The work volume generated will be complicated. We cannot able to show for this. And the mechanical stability will be very good in this, and it can able to perform pick and place. And mechanical stability will be lesser as good compared to this one, because one rotation joint is increased in this. So to compensate that, we'll be using a better controller, and this can able to perform pick and place. This also can able to do pick and place along with a simple welding and the spring operations. And let us come to this. It will be a spherical or segment of a sphere, and the mechanical stability will be not good than these two. So that it required a little more better controller, because two rotational joints are increased this. And the what kind of application will you be using? You will be this can do all these operations what this can do. So pick and place you can do, and it can do simple welding and spraying operations. Along with that, it can able to perform the assembly operations and complicated welding and the painting operations it can able to do. So almost all the industrial robot will be having these three types. Okay, these three types. Now let me come to, you understood the joint arm articulated, this one, and this is vertical joint arm articulated. And if you talk about the horizontal will be like this. Horizontal will be like this. This is a frame structure. Okay, this is a frame structure, and here the robot, this one will be there. That's all. You need not to write a very complicated figure and show that. It's not required. Okay, and here the end effect will be there. At the end of this, there will be end effector. Is it possible, Varun, you can able to write? Yeah, end. It is horizontal SCARA. And it is vertical SCARA. Vertical SCARA. Okay, and now, as now, if you want to discuss something about its features, these robots are having the coordinates r theta theta, r theta 1, theta 2, theta 3, theta 1 at the base, theta 2 in between, and theta 3 there. You can see that this is one rotation, and this is the other rotation, this is other rotation. These are all three will be rotational joints, so that it will be very, very complicated to govern the rotation of these robots. So required sophisticated robot controllers. The mechanical stability of these robots will be very versatile, because all three will be rotational. Okay, and stability and repairability will be not good enough, so that we will be using the better controllers to compensate that. One thing, the work volume generated by these robots will be not having proper shape. These are not having proper shape, and this is very, very important. The work volume you have to show. Okay, work volume, if you show this much, it is more than enough. The work volume of these robots. The work volume generated by these robots I'm talking about. work volume. Correct? No, it is called work volume of the robot. Volume of the robot, you can say. And you can able to, I told you, you can able to divide it into equal parts. It's not a big problem in this. Correct? No, so that these robots are having very good stability, the repeatability and accuracy, and even the mechanical stability of these robots will be very good. Correct? No, are you understanding me?
Yes, sir.
Yeah, good. Just I am showing here only. It is self-explanatory. Self-explanatory. See that all these will be having uniform in shape. And next, let me come to the work volume of this. All these I'll be showing here only, so you can able to remember it. Correct? No, the work volume generated by these robots will be like this. It is called cylindrical coordinate. And if you talk about see, the work volume generated will be like this. Correct? No, it will be smaller here, it will be bigger one. That means the repeatability and accuracy will be very good when the arm is not extended. Once the arm is extended more, the repeatability and accuracy will be poor enough here in this case. Correct? No, and these are called the cylindrical coordinate system. And the spherical coordinate system, the spherical, it will be in the form of a sphere, as I told you. It will be in the form of a sphere. Okay, and a segment of a sphere it will be. It will be just like this. It will be a sphere, spherical shape. In the form of a sphere it will be. You can see that. It will be in the form of a sphere. It is like this. Okay, and even if you want, you can write here also. Yeah, it will be like this. It will be like this. Yeah, I hope you can able to understand this. Now, I was talking about at least along the vertical axis, these segments will be there. These below this, the same segment will be there. Below this, the same segment will be there, and it will be having at least up in the vertical axis, having a good accuracy and repeatability. But in case of these, the spherical robot, it will be very versatile. Correct? No, this is what I wanted to say. Now, where all you can use these giant articulated robot arms. These robots will be used for all kind of applications wherein it will go for the machine assembly, machine vision applications, inspection, testing, any kind of very delicate works it can able to do. Okay, wherever you require, you can use it. Okay, this is what this particular type of robot is. Okay, and any discussion you want to do in this, please tell me. The SCARA robot, the vertical and all these I told. Now, I hope you can able to